What polynomial expression is represented by the squares here? So we talked about algebra tiles, and they're a great way to help you visualize when it comes to completing the square or finding vertex form. So all we need to do first is write what polynomial this would be. That's x squared. We've got 4 x's here, so plus 4x, and then 2 unit tiles, so plus 2. Next, they want us to use these squares, or maybe we just have a process we've already come up with and are comfortable with in general to complete the square or find that vertex form of the polynomial expression. So I'm going to redraw those tiles. There I've got my x squared, and I have 4 x's. So I'm going to split them up evenly. 2 here. Again, you're completing the square, so you're making a square, a perfect balanced shape, minus my bad drawing here. Now we only have 2 unit tiles, so they would go right here. And that sets us up to say, well, we certainly know we could use a couple more here to complete our square. All right, so when it comes to writing the equation in vertex form, we know the length of this side is x, and this is 2 units, like 1, 2, the little short sides, and this is x length, and this is 2 there. So if this was an actual square, it would be an x plus 2 by an x plus 2. That's why we write x plus 2 quantity squared. Then we have 2 tiles up here, okay, but we know we need 2 more. So we could always add 2 more tiles, but you want to write subtract 2 also, because technically we can't just throw more tiles in here. It'll be a whole new equation. But if you add 2 and then subtract 2, it would balance it out. Now, if we were to FOIL or multiply this out for a moment, if we said x plus 2 times x plus 2, our equation would be x squared plus 2x plus 2x plus 4. The 4 tiles are actually in there, even though we don't have them. So when you had to, and you wanted to add 2 more to make that 4, we have to write the subtract 2 to balance out what we did and not actually change the polynomial. So we're going to write the minus 2, and that part right there, very important. This minus 2 comes from the fact that I said if you needed to add 2 to there, the red parts that are missing, to make a perfect square, you'd have to also subtract 2 to keep it at 0, technically. So that is why we write our minus 2, and this right here is our vertex form, y equals x plus 2 quantity squared minus 2. That is equivalent to the original polynomial up there. That was a bad circle. Now, just a quick snippet to bring over and show you. I have gone on Desmos and I've graphed x squared plus 4x plus 2 and our vertex form. And there they are. Hard to see here. Let me show you the graph. So here's my 2 equations, a black one and a red one. If you look at my graph, you can't even see the black equation. And the reason that is because the black equation, the vertex form, and the original equation are the exact same thing. We didn't actually change it. We just rewrote it in a different form.